Okay, it's August 19th, 2010, doing a Fluxgate Magnetometer Current Sensor positional tolerance test. See down here in the left corner is the electronics. That's the sensor head itself in white, placed onto a copper bus bar. Right now, it would normally be clamped, but right now I have the bus bar off so that we can do, or normally clamped, I guess would have a top on it, but right now it's off so I can do some, angle and sliding position sensing to see how the output of the sensor may vary with position. Right now we are at, geez, I don't know if I can see that. Right now we are at 2.4948 volts, i.e. zero current coming through, and there's zero current. Okay, now what we're going to do here is we're going to apply 4.5 amps. 4.5 amps at 40 millivolts per amp should be an additional 180 millivolts. So 2.5 plus 180 should be 2.68. And it's 2.678, but our offset is 2 millivolts low. So you can see that the gain is right on. And of course, yes, that's 4.5 amps. Actually, it's a little low in the ampere. There you go, 4.5 amps. And that's why we were getting oscillation on the output. Okay, because we had a real current change. All right, now, yes, here. Let's see. What we're going to do here now is we're going to take it and slide the sensor to one side, and we still get the same value all the way up against the end, pretty much. We change about a millivolt or so. Now we're going to slide it back to center, and then to the other end. Doesn't start changing a millivolt or two until you get right next to the screw. I can push it up against the screw. I can get a few millivolts there. But anyway, it's back to normal. Now, next would be angles. We can rotate this up quite an extreme angle to get about a 4 or 5 millivolt change, and that's a pretty steep angle on the part. And let's center it again. Let's really exaggerate the angle, and we can really get it to change, but we're talking almost a 30 some degree angle there, I'd say. Again, to get 5 millivolts, I put it back to normal. You can see it change. Let's see in real time. There we go. Maybe about 5 millivolts. And I wish I had something to measure that angle with, but I'd say it's like 15 degrees. So, the positional variation on this is very small. At 40 millivolts per amp, 5 amps or 5 millivolts like that isn't a lot of error, obviously. So it's pretty robust to changes in position. The next one, or last one, I guess, since it's in a cradle, can't really move. The flux gates can't really move themselves. Maybe minuscule amount over temperature, but really it's the construction of it, and even then it would be calibrated out. But I can raise this bus bar up again, get say a 5 millivolt change, and you can see that well, I can move the doggone thing back in. Okay, we're back. Let's start over again. 2.78, and I can move it about halfway off of the bus bar to get about 15-20 millivolts change, about halfway. And of course it depends on the width of the bus bar with respect to the coils. You can make it so that you can move it a considerable amount without a change. In this case 65, 75, 85, so 20 millivolts would be about, gosh, 6 millimeters off the bus bar. So again, very intolerant to position, very repeatable, and 2 millivolts low in offset and 2 millivolts low in the gain. So that's the test.